So we're going to talk just a little bit about validation and verification. Remember from before, when we talk about validation, we really mean that we determine that the requirements are correct. In other words, that the end product is going to perform the intended functions. The intended function that the designers wanted to implement with their system requirements. In verification, you're really going to say that the results of all these design processes you had, development processes you had, are correct and consistent with respect to these requirements. So it doesn't tell you anything about the intended function in the end. You're just saying, okay, I'm having a set of requirements, and that results in a particular product. Is this product performing whatever I specified in the requirements? Yeah. So the DO54 validation process really does not focus on the validation of all the requirements, or at least specifically the requirements that are derived from the system level, that are a result of the system level requirements. It really focuses on ensuring that the derived requirements are correct and complete with respect to the system requirements. Yeah. So remember, the derived requirements are part of the design process itself. They're not necessarily easily traceable to some higher level system requirement, but they're necessary because otherwise your system won't work. So basically what you're trying to do here is try to validate these derived requirements and make sure that they make sense. Do I really need those? Are they correct? And of course, do they still help implement the whole system as a result? Yeah. So that's what I say, the derived hardware requirements. So some of the objectives are that the derived hardware requirements are correct and complete, and of course they must be evaluated for the impact on the safety. So you really need to make sure it's like, okay, this additional set of hardware that I'm defining, that I'm writing derived requirements for, what impact does that have on the safety? Is there any additional things I need to worry about? Because remember, initially we established this functional failure path, and now we come up with some detailed design that we have to bring back to that functional failure path to make sure we did it good. Yeah. So some more stuff. Because the methods are really not different. Reviews, analysis, testing, just like we saw in DO178C. Of course, in this particular case, the reviews are still kind of similar. The analyses are, of course, very hardware-oriented. Thermal analysis, simulation analysis, reliability analysis. These all need to be included here now because they're part of the, the overall safety requirements. Okay, so there's a couple of other things here. We're not going to talk about those too much, some verification activities. But one thing I really want to stop real quickly is what the similarities and differences are between 254 and 178. And of course you've seen most of it already. The number of assurance, the relationship to the system safety aspect. These are all kind of similar in essence as we saw with DO178C. Of course, there's a very strong emphasis on the configuration management, and the verification processes include, again, analysis, reviews, and testing. Is just that some of these tools, like the testing tools, and the analysis tools are different because now they're hardware specific, and so there's a variety of other things you need to worry about. Yeah. So the differences is that you don't see really that much focus anymore on the transition criteria like you saw it in DO254. And the other thing is that DO254 really talks a lot more about the how in addition to the what. And this really comes back to when we established, for example, the design assurance strategies. DO254 tells you a little bit about what some of these strategies are. It talks a little bit more about the how. Now, okay, so we'll talk a little bit about, so that was the hardware, that was DO254. I know I went through this pretty quick. Make sure to read the readings that are provided to you on Blackboard. They give you some additional information, but this gives you a little bit of a flavor for DO254 without going into too much detail. Well, I want to at least talk a little bit about DO297, which is integrated modular avionics. Just to give you an idea, in integrated modular avionics, we try to really come up with one box on which we're going to host multiple functions. Yeah. So in other words, this particular hardware unit is going to host applications performing after functions. So more than one function in one computer box. That's the basic concept if you talk about IMA. Yeah. Think about it, one chassis with multiple cards in it, and these multiple cards may run one or more aircraft functions. Everything is really more integrated. IMA. A whole ton of stuff in that standard as well. But one important thing is that related to the IMA is ARINC spec 653, which we have already seen before when we talked about the PSAC. What that really talks about, it talks about if I run, and you know, there's a whole definition on this slide that I'd like you to read, of course, but what basically it's visualized in this picture the best. If I have a particular chassis, and it's an IMA chassis, and I'm running some embedded hardware, some processor, some board support package, and an operating system. Now on that same board, I want to have multiple different functions running. So for example, I have a software, an ADA program that actually has a runs, is part of a function A, and the safety levels, assurance level associated with is level A. There may be a second function written in C, which is part of another function. Again, a safety level may be A, and B and D. So you see, there may be 4 different software components on this, and these 4 different software components may actually be part of 4 different functions on the aircraft, as per IMA, Integrated Modular Avionics. So if that's the case, what you have to make sure is that you have to partition this very well, that you make sure that these programs cannot have access to each other resources. So you have to perform a very strong resource management. So ARINC 653 really specify the interface between the operating system and the avionics computer resource, think a regular embedded computer, and the application software. Okay? And make sure about things about scheduling, communication with the input output, etc. It's a variety of different things, and it does this very explicitly. So you'll find out there's a lot of products out there that are actually ARINC 653 compliant and D178B certification ready by VxWorks, LynxOS, Green Hills, and a couple of other products. So you can buy products out there that you can put on an embedded processor that would support running multiple different software components in an isolated or in a partitioned fashion to support IMA. So I know this went pretty quick, but this last module is all about giving you a flavor of a couple of different topics.